Algebra 2, this is lesson 3.3. Oh, the title is Optimization with Linear Programming. This is very similar to lesson 3.2, where you solved systems of inequalities and looked for the vertices, but there is one additional step on this. If you'll look at number 1 in your composition book, the first equation is y greater than or equal to 2. A y equals line is horizontal. It has equal to, so we're going to have a horizontal line where y is equal to 2. Because we're trying to find vertices, you need to use a ruler and make your graphs as neat as possible. The second equation has 1 less than or equal to x less than or equal to 5. Well, an x equals line is a vertical line. So there's x equal to 1. Two, three, 4. There's x equal to 5. Okay, you'll notice that the x is in the middle. Therefore, we're shading in the middle. But this says above 2, so right now we're looking at this area. Okay, I'm going to erase that now that I've called your attention to it, because I want us to be able to look at the entire thing first. Okay? The next equation has y less than or equal to x plus 3. The slope is 1. The y-intercept is 3. So you'll go up the y-axis to 3. 1, 2, 3. And the slope of 1 means to go up 1, right 1, up 1, right 1, up 1, right 1, up 1, right 1, up 1, right 1. And all of these have equals, so they're all solid lines. And it says to shade what is below that. So our answer, as far as shading, is this quadrilateral. Okay? The important thing that you need from this is each of these vertices. So this is right 5, up 8. This point is right 5, up 2. This point is right 1, up 2, and this point is right 1, up 4. I'm going to erase the equations out of our way so I can show you how to come up with the last part of the answer. If you'll notice in the problem, it gave you the 3 equations to graph, and then the bottom line has something that looks like this. And the instructions say to give them the maximum and minimum values for that function. This is saying the function f in terms of x and y is 3x minus 2y. So I have my students do a table. This is point. This is 3x minus 2y. And this is value. Ideally, you wouldn't write it all over the graph, but I'm trying to keep it all on the same page for you. So the first point we have is 5, 8. That means we're going to put 5 in for x and 8 in for y. So that's 15 minus 16 is a negative 1. The next point is 5, 2. So we'll put in 5 for x and 2 for y. So that's 15 minus 4 is 11. Then you'll have the point 1, 2. So we'll put 1 in for x 2 in for y. That's 3 minus 4 is a negative 1. And the last point is 1 comma 4. So we'll put 1 in for x and 4 in for y. So we have 3 minus 8 is a negative 5. And you look at the value list, the largest number, which is 11, would be the maximum. You look at the smallest number, which is negative 5, and that's the minimum. Occasionally, students will say, Miss, what happens if, for example, this was negative 1 was our minimum? Then you would have 2 minimums because they're of equal value. One of them is not a minimum and the other one not. They're both the minimum. Okay, let's look at problem number 2, which has y greater than or equal to negative 2. A y equals line is horizontal, and it has equal to, so it's solid. Then you have y is greater than or equal to 2x minus 4. That means we have a slope of 2 and a y-intercept of negative 4. So we start on the y-intercept of negative 4, and the slope is 2. That means to go up 2, right 1, up 2, right 1, up 2, right 1. So the solid line would go here. Okay, and then the next equation has x minus 2y is greater than or equal to negative 1. Subtract x from both sides. So negative 2y is greater than or equal to negative x minus 1. We have to divide everything by negative 2 because we want y by itself. So we have y, and we have to put less than because we divided by a negative, 1/2 x plus 1/2. So the slope is 1/2, and the y-intercept is 1/2. So you go up to half on the y, and a slope of 1/2 means to go up 1, right 2, up 1, right 2, up 1, right 2. And you can put how many ever of those you feel the need to put. Okay, let's go back and look at our equation for a moment. And it says greater than negative 2, y equal negative 2. So that would be shaded this way. Greater than or equal to 2x minus 4. Which would be this way, and then less than or equal to the red equation. So here is your triangle of overlap. If you use light colored matte pencils and then highlight, then the page doesn't get so busy for those of you that have a hard time seeing it. But remember, our answers are these vertices. So this vertex is right 3 up 2. So 3, 2. This vertex is right 1, down 2. This vertex is left 1, 2, 3, 4, 5, 6, left 6, down 2. Okay. Again, I'm going to erase the equation so that we can do our table on the same chart while looking at the graph. You'll just need to expand your space where you're writing. Okay. Our table has the point. Our function this time, in terms of x and y, is 4x minus y. So we'll have the point, 4x minus y, and the value. Our first point is 3, 2. So we'll put 3 in for x and 2 in for y. 12 minus 2 is 10. Then our next point is 1, negative 2. So x is a 1 minus a negative 2. So 4 plus 2 is a 6. And our last point is negative 6, comma, negative 2. So we have 4 times negative 6 minus 2 times negative 2. So that's negative 24 plus 4. So that's a negative 20. You have to graph all equations, shade, find the overlapping region, identify vertices, and last but not least, make table to find max and min. That is the steps. In lesson 3.2,